now we will learn more about structs and another thing which looks similar and is called union. A struct, as we know, contains a sequence of attributes or struct fields, and the struct contains all this. And we will look at well, I should say that the difference between a struct and a union is that the union only contains sufficient storage so that one of the attributes can be used, and not all of them at the same time. Okay, let's look at an example at once. So say we have this union, then we can either use the array or the double B. If we use the array, store something into the array, then we are not allowed to read B, and vice versa, of course. Okay, so let's go back and continue here. So what is new here is that we can use this colon and a number, and this is called a bit field. It says that B is an int with only one bit. Warning, it's implementation defined whether this int actually is a signed int or unsigned int. So even if normally an int is always signed int, when it is a bit field, then it can be unsigned int. These are historical rests from when the first C standard was defined, 1989, 14th of December. C had been used in academia and industry since early 1970s, and there were some different interpretations of this. But this is a compromise, and that's what we have to live with. Okay, so if we really want signed int, then we should write signed int or unsigned int. Unfortunately, or actually fortunately, we cannot write, for instance, instead of 1, we are not allowed to write 1024 and get a very huge bit field. At most, the number of bits in this type without being a bit field is allowed to be used here. So if we have an int, then we are certain we can use 16. It's not strictly portable to use 32, since according to the standard, an int is at least 16 bits. But, well, if we don't want to be 100% portable, then it's fine to use something bigger than 16, but typically at most 32. Well, there is no point in using a 32-bit bit field, then it's better to use just an int, but okay. Bool, we can use that as a bit field, of course. Whether we can use a typedef name, well, typedef name we can use, of course, but this typedef name is for an enum, and that's implementation defined. Okay, and this is an error. We cannot have an attribute which is a function. Instead, we have to use a pointer to a function. We can never have a member function in C, only a pointer to a function. And if we have that, then say we have, let's take T, okay, and for future use I will put, well, no, I will not. So we have T, and so T is this struct, then we can say T and H is set to a function. Okay, we don't have to use address of function it's permitted, but just pointless. Just write this function pointer is assigned the value of fun. The name of a function without parentheses is automatically converted to a pointer to this function. Okay, and when we use this, we can write, well, we can take the simplest first. T, H, and, well, the parameters. Okay? Or what I think is more preferable is to have T, H, and I mean the star here, to make it clear that we have a pointer. So these are equivalent. And the reason for that is beyond the scope of this course, but you can, whenever you have a function pointer and you use it for a function call, you can skip the star, or in fact you can use any number of stars, but don't do that. Just use either none or one. Okay. Otherwise it will just look crazy. Okay. So if we have this, then we have an invalid program, but previously at least it was accepted by GCC. And it's a way to create something that we will come to very soon, called a flexible array member. But I will talk about it later. Okay, let's go back to this union. So we can either use A or B. And what is the size of a union? The normal view is that the size of the union is the size of the largest attribute. But so it's not correct. So in that view, the size of the union would be 9. Okay. However, due to something called alignment, it's the previous hypothesis is false. All types except car have a desire to be at an address which is a multiple of the size of the type. Well, it's not the type that wants that, but the variable. Okay, so this B, this is 8 bytes. It wants to be at an address which is a multiple of 8. Okay, so well, that's fine. They both will be at the offset 0 from the beginning of this union. So there's no problem, you may say. But if we have an array of this union, so we write that union U and then A, and well, let's have 4. So what will that be then? So this one will start at something looking like 0. I mean, the compiler will make sure that A starts at a multiple of 8. Okay, and then let's say this is 9 bytes. Then A of 1 dot B, that's a double, but it's not located at an address which is a multiple of 8. Instead, it's at 9 relative to the beginning. So that's it doesn't work like that. Instead, what should it be? This size should be as small as possible, but still making this aligned on 8, so it should be 16. And the union will be here, and this is empty. I have mentioned things like this before, and it's called padding. With an A. Okay, so B will be the first here, and A, I mean the last element there, will be this byte. So now you know, which many C programmers don't, that the size of a union is not the size of the biggest member, but instead we have to take alignment into account.